we have secant times cotangent times sine. What do we want to do here? Change as much as you can. Okay, what can I change from number 1? 1 over cosine, yep. Okay. Good, cotangent can be changed. And then do I want to change sine? No. Sine is the simplest form. I would leave it as that no matter when you see that, no matter what you're doing. Leave it as sine. Don't ever change it to something else. Okay, it's all multiplication. There's no addition or subtraction in between, so what can I do? You can just cancel off. Because you're technically multiplying, and then those are actually dividing out. So your answer is just 1. How many got number 1? Just fine. Perfect. Okay, then they get harder. Cosine times 1 plus tangent squared. How many tried to change tangent to sine squared over cosine squared? Okay, perfect. So when you see anything squared, what should you look at on that identity sheet? Which one?
Identity.
Yep. This is a Pythagorean identity. Okay? So anywhere I see that, what do I replace it with? Right, it's just secant squared. Do we need to see how we get that? Or where it comes from? As long as you have your identity sheet, it's right there. Okay? Now, what can I change from here? Secant, I can take that. Yep, was that what you were going to say? I would do that, yeah. You technically do have 2 secants there. You can separate that, or you can just go and say, well, secant is just 1 over cosine, but I've got to remember I have 2 of those. So if I change it to 1 over cosine, I got to change it to 1 over cosine squared. Okay, because you have the secant squared. Now if I multiply straight across, I have cosine over cosine squared. 1 on top, 2 on bottom. What am I left with? 1 on the bottom. So it's 1 over cosine, but again, that's a fraction. I want to try to leave my answers as whole numbers. So it's just secant x. Number 2, are we okay? Okay, so those 2 didn't give us too many issues. Alright, what about number 3? Tangent of x times sine of x divided by, don't overlook that, secant squared minus 1. What should I do here?
Secant squared minus 1 is tangent squared x.
Very good. Pythagorean identity. So I have tangent on top times sine divided by, now anywhere I see secant squared minus 1, I will plug in what that is equal to, and it's equal to tangent squared. Do we need to see where that comes from? Just the Pythagorean identity manipulated. Pythagorean identity. There we go. Thank you. Did I? Sorry. Usually I'm used to writing Pythagorean theorem as PT. We can problem solve, right? Now what do? You can cancel out 1 tangent. So 1, 1, which leaves me with sine over tangent, which I can change tangent now. Now, here's the thing. Yes, this is simplified, but think of it as a fraction that I can keep dividing things out of. Okay, so that's what I'm going to do here. So you guys said tangent can become sine over cosine. But now I have a number divided by a number, so copy that, flip. So I have sine of x, I'm going to multiply, oh, I'm running out of room, times cosine divided by sine. So what am I left with? Cosine. How many got number 3? Okay. Where did we get stuck on this one if we did get stuck? Anywhere? stuck anywhere? Okay. How about number 4? What'd you guys get an answer of for number 4? Secant. Alright. That is what you should get. So, walk me through it. What'd you guys do? Okay, so you're not touching that 1 first. Okay? So then we see this tangent squared. What did you do with that? Yeah, you gotta put in the -1. Okay, you have another identity there. So instead of changing everything to sine and cosine, find that Pythagorean identity. So you end up having secant squared x -1 on top, all over 1 plus secant on the bottom. Now, don't try to get common denominators. This one will be difficult because you have that 1 plus secant in the bottom. So what should I pay attention to in this problem? Well, technically we can't divide that out because of that addition there. But that's a good idea to look at if there weren't the adding and subtracting. Right. This right here is basically like having x squared minus 1. What is that called? Yeah, binomial. But what? Because I can write many binomials. This one is a specific type. We talked about it yesterday. Where we had x squared minus 9. Difference of squares. Yep. Okay, so if I write it kind of thinking about x squared minus 1 in mind, so I'm leaving the 1 plus. So I've got to get 2 sets of parentheses on top of this denominator. Technically, in sine squared x minus 1, what is my variable? What's my x? That would be the secant. Okay, operation, what are my constants? What are my numbers? 1. Alright. Now, with the difference of squares, 1 has to be positive, 1 has to be negative. Okay, so if I actually go through and FOIL this, to get secant squared, I take secant times secant squared. Then in the middle, I'd actually get secant negative, and then secant positive. So a positive secant and a negative secant cancel off. And then a negative 1 times a positive 1 gives me that negative 1. Okay, so it's basically just doing this, but now with trig. Okay, so you just have to remember when I see a trig function squared minus 1, 9 times out of 10, you want to factor it down. Make sense? Okay, now multiplying straight across and dividing out, what divides out? Here. Now, it's written differently, right? Secant plus and then 1 plus secant. Does it matter? Right. Since it's addition, it doesn't matter. Subtraction does, however. Okay, now I'm left with 1 plus secant of x minus 1. Move stuff around, what cancels off? The 1. Leaving us with the whole number. So how many got number 4? Did you get there right away, or did we have to think about this for a little bit? Think about it? Okay, did you change things to sine and cosine? Okay, we'll look at it in a minute. Alright, any questions 1 through 4 so far? Alright, let's look at number 5. Tangent times the quantity sine plus cotangent times cosine. In that second set of parentheses, how many terms do you technically have? You only have 2. This is the same thing as if I had 2 times 5 plus 5x. How many terms do you have in that parenthesis? You only have 2. So here it would be 10 plus 10x, right? Not 10 plus 10 times 2x, correct? Okay, so if I do this with the trig, I'm only distributing that to 2 things, not to 3. And yesterday I kind of saw that common mistake here. You have the right idea, though, that you need to distribute. So, yep.
Why are you distributing?
Because these right here are being multiplied, just like these right here are being multiplied.
Okay, yeah.
So do you always recommend distributing and whatnot before you change any of like the tangent into?
I would, just because it's easier to write it like this instead of all the fractions.
And then go and do the fraction. That's fine. Okay.
Does it matter? Absolutely not. You should still, I mean, you'll just look at
Well, you would recommend it like
just
these.
just because it's easier to write it out, and then you can see a little bit easier what I'm gonna cancel out.
Okay.
Alright, so then I have plus tangent times cotangent times cosine. Alright, sine over cosine times sine. I can simplify this a couple different ways. I can go down to sines and cosines. I can change tangent in terms of 1 over cotangent. I can change cotangent in terms of 1 over tangent. I don't care which way you go. You're still going to get the same thing. So I'll just change the first one into what the second one is. And then I still have times cosine. So on the left here, I get sine squared over cosine plus what's going to happen here in the middle. Everything cancels down to 1, leaving you with just cosine. But I don't want to leave this because I can still simplify that, correct? A fraction plus a whole number, how do I add those together? I gotta get a common denominator. What is your common denominator going to be here? It's going to be cosine. When you multiply by a common denominator, it's got to be to the top and to the bottom, so that's what's in red. So I'm going to come over here. Do I touch the left side of that addition sign? Nope, it has a common denominator, so I don't mess with it. So I have sine squared x over cosine of x plus, what do I get on the right side now? And you guys should be very happy to see that, because when I put that together, what does the sine squared plus cosine squared become? It becomes 1. And that is the Pythagorean identity right there. So that becomes 1 over cosine, but I have a fraction. I want a whole number. So it's secant of x. Does that make sense? Okay, so I went a little quickly with that, but are we all following? Okay. Right there. So how many got number 5? A couple of us? Where did we get stuck, those who didn't get it? Yeah, because, yeah, really just was because there's no addition or subtraction in between there. Yeah, that'll just be like a variable in it. Good one to point out. Any other questions on this one? Okay, number 6. What did we get as an answer here? It should be sine of x. Okay, so what do we want to do here? What should we do first?
I changed the numerator in 1 over cosine
Okay.
and the denominator into sine over cosine, so that's perfectly fine.
Very good. That is where, if you look at this problem and you say, I have absolutely no idea where to go and what it's going to simplify down to, That's where you want to start. What pieces can I simplify? And I'm going to simplify those.
Wait,
Yep. Multiply. Multiply, they go down to 1. But because it's addition, you'll have to get common denominators. Yep. Okay, so I'm not going to do anything with that top, because I pretty much have done it all already. So what am I going to have to do with the bottom? I have a fraction plus a fraction. You got to get a common denominator. What will the common denominator be? Right. And I'm going to write that over here. But now I'm going to write over here what I need to multiply by. So the right-hand side. What am I missing from my common denominator? I'm missing cosine. So I got to put that top and bottom. I'm going to multiply it. Make sense? Okay. I'll show you what this looks like in terms of numbers so you can connect it. But what am I missing on the left? I'm missing sine. Yep. 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 So now on top it's sine squared of x plus cosine squared of x, and you should jump for joy when you see that, because it goes down to 1. Alright, so now I have 1 over cosine of x is equal to 1 over cosine of x times sine of x. Okay, so are we okay here? Stand here. Now we have a fraction divided by a fraction. 3 words. Copy that, flip. So I copy down the numerator. I change it to multiplication. Now what am I actually going to multiply by? Yep, cosine x times sine of x over 1. So then I multiply straight across, and I can divide out what? I can divide out cosine, leaving me just with sine. Okay. Now, some of you looked a little confused when we got a common denominator. If you had something like 1/3 plus 2/5, you don't see a common denominator in one of those, correct? Okay, so what would a common denominator be between 3 and 5? It would be 15. So what are you missing in the 1/3? You're missing 5. Excuse me. And then in the 2/5, you're missing 3. That's what we're doing to get this common denominator. Does that make sense? Okay.
So wait, and so you don't have to multiply like sine.
Like here? Yep, because you just put it together over here. What number was this? 6? Okay, do we feel better with that one? Okay. Alright, let's take a look at number 7. 1 plus secant of x divided by tangent of x plus sine of x. My division. I can't divide anything out as it is because there's addition and subtraction. The only time I can do that is with division, with the multiplication. So, what should I do? No. You don't want to. Because what would happen, since tangent and sine are technically our whole numbers, when you copy that flip, that would become a fraction, which would pretty much get you back to where you're starting. Alright, so what do I want to do? I don't see where I can go. I don't see anything I can divide out. So what should I always start doing? Simplify. So 1 plus secant. I could do 1 plus 1 over cosine. Let's just try that. We'll see if it'll help us. Divided by sine over cosine plus sine. Okay. I'm going to stop you here before we go any further, because I want to bring up one algebra strategy that we didn't really look at yesterday. If you have, let's say 2x squared plus 10x. What do you notice about those two terms? They both have an x. They're both divisible by 2. So let's divide those two things out. So I can take out a 2x. What's left here? X. What's left here? Okay. So now, let's look at the denominator again. I'm going to leave 1 plus 1 over cosine. And now looking at those two terms, I have a fraction, I have a whole number. What's in common with both of those? Sine of x. So let's go ahead and divide that out. So what am I left with here? 1 over cosine, yep. Plus 1. Now, I'm glad we simplified the top, because what do you notice? They're the same thing. So that actually all will cancel out. So we just have 1 over sine, which I want a whole number, which Allie said is cosine. Now, could you have gone and found common denominators and done all of that? Absolutely. It would have taken you triple the space. Does that make sense? Okay. So a lot of times, if you get down to here and you have that common term, try to pull that common term out because it might help you cancel off the numerator. Not always, but it might. Okay? Any questions on that one? One second. Let's read answers real quick, guys. Just so you know you have them right. Okay, so number 8, and we'll go through a couple more in just a minute. So number 8, what did you guys get for an answer? Cosecant squared x. Number 9, you should have negative tangent squared x. Number 10, you should have cosecant squared x. Number 11, you should have sine squared x. Number 12, you should have cotangent. Number 13, you should have cosine. Number 14, you should have secant. Number 15, you have sine. Number 16, you should have secant. Number 17 is different. You should have 1 plus 2 times sine times cosine. So again, 1 plus 2 times sine times cosine. And then 18, you should have cotangent. Alright, so I have 1 plus tangent squared on top divided by tangent squared. Now, I cannot divide off those tangent squares. There's addition on top. You can't do that. So if I see a 1 plus a trig function squared, what should I look at? The identity. This is an identity, correct? And it's secant squared. So now I can go down to secant squared over tangent squared. But again, I can simplify that even further. What's on top? Yep, 1 over cosine squared x. Please don't forget the squares. Fraction divided by fraction, copy dot flip. So 1 over cosine squared x times cosine squared x over sine squared x. Multiply straight across and then divide. The cosines will cancel off, leaving you with 1 over sine squared. So cosecant squared.